First of all, with numerical data, if it's pertaining to the whole population, that's called a parameter. And if the data is from a sample, that's called a statistic. So take a look at this example. First of all, think about the average age of Hartnell students. You want to take a guess at what the average age is? Well, it turns out that it's 26.3. But look at these two different notations. The one on the left is called mu. So this symbol right here is called mu, and that stands for the whole population. That's to say all, whatever it is, 10,000 students at Hartnell. If there was a sample, then we would be using this x with a bar over it. So the one on the right is a statistic, and this one would be a parameter. So mu would be the parameter, x bar would be the statistic. So there's two main types of data, qualitative data and quantitative. So quant is referring to a quantity, and qualitative is referring to a quality. So a quality would be something like a name, a gender, etc. And then, let me go back, and I just thought of an example. Like if you say that somebody's old, well, that's a qualitative data. But if you say they're 83 years old, then that's a quantity, numerical data. So anyway, when you get to the quantity, which is the numerical data, there's two main types for that. There's discrete data, which is countable. So these are going to be things where you can go from one object to the next object, and there's nothing in between. So with having children, so the family is going to have 3 children, or they're going to have 4 children, but to say something in between like 3.64 children makes no sense. It's either 3 or it's 4. So in this example, they have 4 children. Then, if it's not discrete, it's continuous. So this is usually used for measurement. So this is something where when you've got 2 data points, it is possible to have one in between. So when you say somebody is 67 inches tall or 68 inches tall, well, in between at 67.883, is it possible that somebody could be that tall? The answer is yes. So in that case, the decimals make sense. So this is a way of classifying information, and these basically build up. So nominal is going to have the very, very basic, then we'll build up to the next one, build up to the next one, etc. So nominal, the nom is referring to names. So as you can see, gender is a type of name, male, female, color of your hair, race or ethnicity. So ordinal means there's an order. So for example, with the previous one, with the gender, there is no first gender. You can't really say women are first, men are second. Same with color of hair. But if it's something that you can put in order, like grades, and A is the best, and B is second best, C, and then F is the worst, those can be put in order. So that's ordinal. But subtracting them has no meaning. So if I say, oh, I got a C minus an F, well, that doesn't make sense. That's not possible. So we need another level. And this is called the interval. So if you think of the interval from 1990 to 2014, well, those years can be put in order, but now subtracting makes sense. When you subtract 2014 minus 1990, you get 24 years. So someone would be 24 years if they were born in 1990. But the only thing this one is missing is a 0. So there is no starting point. If you think going back in time, So if you go back 2014 years, that's not when the world started. Some people would disagree, but not many. Anyway, so you go back, you could go back to before Christ. There was BC, etc. So there is no starting point. There is no zero where the whole thing started. So we need one more, and that's called ratio. So it would include the previous information, but it does have a zero. So for example here, the distance between two objects. So you could find the distances, you could put them in order, you could subtract, and it's possible to have zero. For example, if I was holding a cat, what's the distance between me and the cat? It's zero.